All right, welcome everyone. We are working on our unit that's entitled Solving Systems of Equations and Inequalities, Linear Equations and Inequalities. And so this particular lesson is entitled Solving Systems Using Substitution. All right, there you go. And so most of you, I'd say 99% of you, you all know what substitution is. Any of you who play a sport, you particularly know what substitution is because it's the process of replacing one thing with something else. So when you play a sport, you know that if your coach substitutes a player, you're replacing one player with someone else. And so the substitution, the idea is still the same in math. We are replacing one equation or one expression with something else, or we're replacing a variable with something else. But it's the whole idea of replacement. So we're just going to jump on in. We're going to start with something that's really pretty simple. The easiest substitution, of course, would be, and it's going to say solve, and remember this is system, so we're going to be given two equations most of the time. And so if I said that y equals 2, and then I gave you x plus y equals 3, while you could look at that and see, you know that you could replace this y with 2 because you said that's what y is. So you'd have x plus 2 equals 3. You're going to subtract 2. So x equals 1. And then notice one of the things I want you to know is you should write your answers as ordered pairs. So it's going to be 1 comma 2. And there you go. That's really what substitution is all about. One thing you should be aware of, we usually probably don't give you problems this simple, but if we did, that would be so easy to do. So let's move it up, ratchet it up a little bit, and let's do something a little more complicated. So here we're going to call this 1a, and so the system I'm going to solve here is y equals negative 4x plus 12, and then the second equation is 2x plus y equals 2. Now, one of the things you're looking for, I'll be honest, of the methods that we will be using, which is solving by graphing, solving by substitution, solving by elimination, I personally, and probably a lot of people, use elimination the most of the time because the problems are set up for it that way. Now, I don't mind using substitution, and this particular problem, if you look at 1a, is definitely a substitution problem. Why? Because you already have one of the variables isolated or by itself. And so that's one of the things that you need to see that needs to happen is that you need to have the variable isolated already. All right? One of the variables needs to be isolated or by itself. That makes substitution easier. And so we're going to go ahead, and what we're going to do is, we know what y is here because we've said what it is. I'm going to replace this y with this expression. So that means I'm going to have 2x plus negative 4x plus 12 equals 2. So you see I replace this y with this expression. That's what you need to be paying attention to. Now at this point, this is what we've been working on with the daily checks every day. We are now going to combine like terms and solve for x. And then once we get x, we'll substitute it back in to get y. So we're going to have 2x plus a negative is the same thing as minus, so minus 4x plus 12 equals 2. So I'm going to go to a new screen, and so let's keep in mind that we're going to have a negative 2x plus 12 equals 2. Now let's go to a new screen. Okay, and so I said it was a negative 2x plus 12 equals 2. I'm going to subtract 12 from both sides. And so I'm going to have a negative 2x equals a negative 10. Divide both sides by negative 2. And x equals 5. Now that I know what x is, now you can substitute it back into either of the two original equations. I'm going to pick the first one because it's already set up for it. So I'm going to take y equals negative 4x plus 12. I'm going to replace x with 5. And so I get y equals a negative 4 times 5 plus 12. Y equals, sorry, this is a negative 20 plus 12. Y equals negative 8. So my ordered pair is 5, 8. Now, there's always a possibility that you might have gotten it wrong, so what you do is you substitute it back in and you check and make sure it works. Okay? And so, whoops, and that's a negative. Sorry, I missed that. I'm going to substitute it back into the second one. So if we have 2x plus y equals 2, I have 2 times 5 plus 8, negative 8 equals 2. I keep forgetting that negative. I'm so sorry. I don't know what it is about that. Let's change that. And so minus or plus a negative 8 equals 2. So you're going to have 10 basically minus 8 equals 2. So you have 2 equals 2. This works. Problem's good. Okay, let's try another one. So I'm going to go to another screen. And this one is going to be example 1b. And we are going to solve. And this is y equals 2x. And then this one is 3x plus 4y equals 11. Now I know what y is, it's 2x. So now instead of giving you just a number, I am giving you, I'm still giving you an expression, it's just not as long. So I'm going to take 3x plus 4 times 2x equals 11. The 2x came from this equation right there. So please don't forget it just because you're just using one. Now let's simplify this and solve. So 3x plus 8x equals 11. 11x equals 11, so x equals 1. Okay, now that I know what x is, I'm going to substitute it back into this first one. And it doesn't matter which one you pick, I just always pick the easier one. And if it's already isolated, I just pick that, or the one that has the smaller coefficients. I just don't want to do a lot of work. You're going to get the same answer no matter how much work you do. So we're going to have y equals 2 times 1, so y equals 2. So my answer is 1, 2. And there you go. Alright. Now, the next example I want to do is, notice in all of these examples, we had one equation that was already where y or x was by itself. But what happens when it's not? That's when you're going to have to do a little bit of manipulation and figure that out for yourself. So let's do example 2. And example 2, we're going to solve. And it's x minus 2y equals negative 3, and then 3x plus 5y equals 24. Now, what you're going to do is you can pick either one, but what you're trying to want to do is probably eliminate fractions if at all possible. I look for variables where the coefficient is either 1 or it's a number really small. In this case, I'm looking at this x. It already has a coefficient of 1. So it's not going to take much to change this first equation. So on the first equation, if I add 2y, and I'm going to put this in red just so you can see that. Sorry, it didn't click. So if I add 2y to both sides, this equation I'm going to have is x equals 2y minus 3. Alright, and then I'm ready to just take this and replace the x here with this expression. Again, all I did was move the 2y because x already had a coefficient of 1, it's by itself. So I'm going to have 3 times 2y minus 3 plus 5y equals 24. So it's going to give me 6y minus 9 plus 5y equals 24. So that's going to give me 11y minus 9 equals 24. I am now going to add 9 to both sides. And I'm going to get 11y equals, looks like 33. So y is 3. I divided both sides by 11. Now that I know what this is, I'm going to replace this the y in the first one with 3. And I chose the first one because it's just easier to work. Now I'm going to work with this one because I've already kind of simplified it and I know that it's correct. And if you know that, then it doesn't really matter. I usually always advocate that students go back to one of the original ones. This is pretty close to the original. So x is 6 minus 3, x is 3, so my ordered pair is 3, 3. Now another thing you can do is if you want to graph each of these systems, because we've already done a lesson on graphing, I promise you if you graph them, that should be the ordered pair that you get where those two lines cross if you do it correctly. So just a little heads up, I kind of wanted you to see that. So we're going to go ahead. I have several examples that I want to get through, so I'm going to go ahead and do that one. So this is going to be example 2a. And this definitely is one of those lessons that really, guys, just takes a lot of practice. And so that's one of those things I want you to do. And then the word problems we'll work on together in person rather than on a podcast because students do struggle with those. And sometimes I do too. You just have to be willing to put in the work if you can't figure it out. Alrighty. Now, I think I'm going to get this y by itself because it has a coefficient of -1, but it's not going to take a lot to change it. So I'm going to have 3x minus y equals -12. I'm going to subtract 3x from both sides. When I do that, I get -y equals -3x minus 12. But I need y, not -y. So you can either divide through by -1 or I'm going to multiply through by -1. So y equals 3x plus 12. If you notice, all I did was change all the signs. Make sure you go all the way across the equation and then it doesn't matter. So now I'm going to replace this y with 3x plus 12. So we're going to have a -4x plus 2 times 3x plus 12 equals 20. And now we're just going to simplify and solve for x. So you should notice this is very similar to what we've been doing on the daily check. So hopefully with that and this, it just helps those get so much better. So we're going to have a -4x plus 6x plus 24 equals 20. So we're going to have 2x plus 24, that's x, equals 20. I'm going to subtract 24 from both sides. So I'm going to have 2x equals -4, so x is -2. Now that I know what this is, I'm going to replace this x with -2. And so I have y equals 3 times -2 plus 12. So y equals -6 plus 12, y equals 6. So my answer is -2, 6. Always make sure you write your ordered pairs as x comma y. Otherwise you could get it wrong just because you put it in the wrong spot. Alright, please feel free to pause or replay this or rewind it as much as you need to. Next page we are going to do example 3. I just have 2 more and then we're actually done. And then definitely try the homework because it really does take practice. Okay, so this one is going to be 2x plus y equals 8, and then x plus y equals -2. Now, it really doesn't matter which one of these we pick. We're going to solve one of these for x or y. I'm going to solve for y, nothing special, I just want to. Okay, so I'm going to subtract x from both sides here. So when I do that, I get y equals -2 minus x. There's nothing special about the order, I just didn't see any reason to change it. Alright, so that means I'm going to have 2x plus 2 times -2 minus x equals 8. So let's simplify and figure out what x is. So I'm going to have 2x minus 4 minus 2x equals 8. 2 times a -2 is a -4, and 2 times a -x is a minus 2x. So now I'm going to combine like terms here. So if I do 2x minus 2x, that becomes 0. It just falls out. So I end up with -4 equals 8. Well, now we all know that's not true. It's not ever going to be true. And so what this tells me when I work this problem out is that this is a no solution problem, because there is no x or y that I can put in that's going to make this work. There just isn't. And so I want you to see that. So when you solve algebraically, which is what we're doing with substitution and elimination, you are possibly get the same type of answers. You really do. So remember, we talked about it. They cross at a point, which gives you an ordered pair, which is the first few examples we did. This one, they must be parallel. If there's no solution, it means they're parallel lines because they don't cross. And so, for example, 3a, obviously, that's going to be a mini solution. So let me show you what that looks like when you do that. And it's not as bad as you think. So, example 3a, we are going to solve 3x minus 2y equals 3 and -6x plus 4y equals -6. Alright, so now one of the things that I always notice when I'm looking at a problem is I notice if I take this first equation and I multiply it times a -2, okay, sometimes if you just look, you should be able to see right away that if I double the first one, I get the second one. If I multiply it by a -2, then what I'm going to get is I get a -6x plus 4y equals -6. Well, you should notice these are exactly the same. So that should tell me that this is a mini solution problem, many solutions, which means the lines are the same or they coincide. So what you're looking for when you're looking for a many solutions problem, one equation is the multiple of the other equation. In other words, if like I did, multiply it times a -2. But for somehow if you multiply one of the equations by the same number all the way across, you get the second equation. So it could be 2, it could be 20, whatever. But you're going to get the same equation. And so that helps you in that if you see that off the top of your bat, you don't have to do a whole lot of work because we can all see that. I don't expect you to sit here and work it all out when you can tell me, oh, if I double this one or multiply it times a -2, it works. So that's what I want you to make sure that you try. All right. So those are the examples that I wanted to show you. I wanted to show you what that looked like. The other thing with a mini solution problem, that if you did work these out, what you usually see is you get 0 equals 0 or -6 equals -6. You get the number equal itself, which means everything works. That's what it means. On many solutions is everything works because they have the same ordered pairs to make up the lines. So thank you very much, and we'll see you on the next one.